Hi, welcome to the December 2nd meeting of the Kubernetes VMware User Group, which covers running all forms of Kubernetes on VMware infrastructure. We've got one agenda item for today's meeting that was suggested at the end of last meeting, and that is to hold a discussion and share ideas about best practices for high availability running Kubernetes hosted applications and services on top of VMware infrastructure. I did not get an authoritative speaker for this group. It was a little trouble trying to line something up after the US Thanksgiving holidays, but I thought that maybe we could just have open-ended discussions and ideas shared here and focus it a little, and then maybe sometime next year, if we've targeted specific areas, I should be able to recruit expert level speakers on specific areas. I'll say a few remarks just to get things started, and then I think Miles told me that he had a few things going too. You know, one of the things I've pointed out to others in the past who asked me about high availability for this is there's often some prerequisites that involve things that you maybe could run in Kubernetes, but perhaps if you're at an edge location or an on-prem that is subject to disconnection or bad service from the cloud layers or the internet above, one of the issues with high availability is putting in place these prerequisite features, which I'd say include identity management, a load balancer for the Kubernetes API, DNS, IPAM, maybe an image registry so that you can recover from a power cycle without waiting for internet connectivity to come back, or without facing maybe a bottleneck because your internet connectivity is finite and limited. So those are some things that, for the most part, it's entirely possible to host things like your identity management in Kubernetes, but it could lead to these chicken and the egg scenarios where you need it at a restart, but it isn't available yet because the thing hosting it isn't there. And luckily with VMware infrastructure, you may be able to host those on VMs, taking advantage of high availability features. And it's possible that would be a good idea in some scenarios. So those are just a few ideas I'll throw out there to get us started. And Miles, I think you had some remarks too.
Yeah, so with regard to availability and stuff like that, I guess it makes sense to chat about what is availability in the context of a modern app on Kubernetes, and then in the context of a modern app on Kubernetes on vSphere, because we assume because vSphere is underneath it that you're going to use the vSphere features for HA as well as the K8s features for HA. But there are circumstances where, HA at vSphere plus HA at Kubernetes does not equal more HA. It actually equals less HA and greater operational complexity and that kind of thing. So I think it might be worth talking about when does it make sense to use certain features in K8s, and when does it make sense to use some of those features just natively in hypervisor or vSphere. Also, maybe from the app layer as well, because like Steve was saying, if you're having network disconnections and it is at an edge location or something like that, if you have something on that premises, say it's a retail store that has a bad uplink or whatever, and it still needs to process transactions, how do you do that while the central location is offline, and how does that sync back up over time as well?
So table's open for anybody else to make comments or try to steer this in a direction you're particularly interested in with questions or observations, recommendations. Just go for it. It's a small enough group. I think we can maybe just try speaking up when you feel like it, and we'll see how that works. If we get a lot of people bumping into each other, we'll go with hand raises or something.
So this topic's interesting for me right now because I'm busy writing some TKGEI designs still for some customers. And one of the things that I noticed, and it's one of the reasons I thought this was an interesting topic to cover, is you don't see much guidance from vendors, including VMware, around going across the whole stack. When these things meet up. So what I've been doing in some of these design documents is creating chapters specifically on availability, where these worlds do meet, and it's interesting because with vSphere you end up usually with basically mapping onto DRS in some way, and taking the effects of HA into account, and TKGI is even a little bit more interesting because it's got Bosch underneath, and Bosch has various features and functions like the Bosch Resurrector that also adds to that mix of which things can help bring back a certain functionality. They all do it slightly differently, and timing becomes a thing. I haven't recently looked into the TKGM documentation, but I can't remember what the current state is in 1.4 of I'm sure Scott will know exactly of the support for either DRS or at least the ability to do. I remember they introduced some kind of placement logic stuff, and I can't actually remember the details anymore.
vSphere topology of availability zones. It's available in TCE, cluster API, upstream. If we're not going to talk product necessarily here and be a bit more open, it's the same thing in cluster API as it would be in TKGM or TC or anything else built off of cluster API vSphere, where there is support for availability zones, which can be either clusters or host groups. And then you have regions, which would be data center or cluster. There is still, in cluster API, there is still no support for multi vCenter clusters, which you can do in things like Rancher or I don't believe OpenShift supports that, but there are other distributions. If you were just to do a pure kube ADM, you could do that. That's not in the cluster API abstraction as of this point, nor in TKGI, because Bosch is also single vCenter. But basically, what we're seeing, at least from our side, is more use of host groups, because that's something that, in the end, HA of vSphere, and the same issue that exists in Bosch exists in cluster API, because there you have machine health checks. And there it's even worse than the Resurrector, because it actually just deletes the VM and recreates it, and it tries to delete it while it's in the middle of doing an HA failover, and it can get a lot of fun can happen there. But in general, what we're seeing is host groups make a lot of sense, because the last thing you want is for all of your applications to run on the same ESXi host that crashes. So what we're seeing a lot of times is people will take a cluster, break it up into a bunch of smaller host groups, of even if it's single hosts. We're seeing that actually in a lot of cases where they'll create up to 64 availability zones. But that way, when you create with pod distribution budgets, and you can actually deploy your pods so that they are always running on nodes that are on different ESXi hosts that way. And then you make sure that even if an ESXi were to fall and you had 4 worker nodes, let's say, running on there, your pods, you know that only one replica went down if one ESXi host goes down. So I think that HADRS are less important a lot of times, especially in the immutable infrastructure type Kubernetes deployments. Rancher is using cluster API now. OpenShift is using the machine API, which is similar to cluster API. It's really becoming the standard for on-premise deployments as well as cloud deployments these days that aren't managed services. But making sure how to separate onto different hosts your pods has become the real key factor. And I think host groups are the way of doing that today in the least complex way of doing it.
Yeah, I think we end up mixing because the bulk of us come from the infra land, so we are aware of the infra availability concept and try to map those upwards. But a lot of times the reality is that whenever you deploy stuff onto K8s, if you're using like PDB, pod disruption budgets, or specific placement that allows things to be placed across K8s nodes like anti-affinity or pod anti-affinity or whatever, you have to be able to assume that each of those K8s nodes is on a different physical host underneath to ensure that that availability concept actually maps through. Because otherwise, if you have DRS rebalancing stuff and you've got 2 K8s nodes on the one host and it goes down, well, then your pod disruption budget and your anti-affinity is not really anti-affinity, and it doesn't really apply whenever it comes to failures.
Exactly. That's always been the issue that we've seen many times with any Kubernetes running on vSphere is what? But we set it up to run on 10 replicas. Yeah, well, all 10 worker nodes were scheduled on the same ESXi host. Sorry, your application is down. And that's really the difficulty when you talk about the cloud, you don't need to care about this, right? When you're talking public cloud, you don't care what the hypervisor they're using or how it's running there. You just know that you get the availability. And that's all dealt with behind the scenes. Here, you kind of have to deal with that as well, which requires a lot of tagging and things like that, which brings up the really interesting one of how it was done. In the end, back when we did the session on VBA on the user group a few months ago, one of the things I had shared, there was a function that we actually built internally that tags virtual machines and places them into different host groups as well. So even for systems that may not be cluster API based with availability zones, there are ways of doing this as well in order to set up those host group, affinity things. But the one consideration there that's very important to note, because they are tag based, most of these solutions, be careful of how many tags you create. In large clusters, it can get complex. vSphere has a wonderful new REST API and a interesting SOAP API, but its tagging is very strenuous on the API and can cause issues. So you have to be very careful what tags you send and how many tags to set. And it should always be the bare minimum possible to get what you need, because it can destroy the VAPI in large environments.
Scott, do you know in CAPI, is there, or not CAPI, but CAPV rather, is there any work going on with regard to the machine sets allowing to set, for example, an affinity policy for the nodes within a machine set or across machine sets or anything like that?
So the answer is not really, but what is coming in is the ability to tag the virtual machines. So that would allow that with like a VM rule that you could create in a DRS rule that would just say separate, and then you could do that tag based kind of. So there are ways there is a PR that I believe was merged. I think it's in V1 beta 1 of cluster API though. So that would be V1.0.0. So not in any products out there today of any vendor using CAPV, but hopefully soon. But if you do just use the upstream CAPV, there is the ability to add tags to the virtual machines, which can help or achieve that. The issue and the reason I don't believe that that's in CAPV or in any of these providers today really is because there's a very strong notion that availability zones are mapped to a machine deployment is in one availability zone. There is no way to stretch a machine deployment across availability zones. Create multiple machine deployments is the idea of how that is supposed to be set. KCP on the other end, the KubeADM control plane, that is meant to stretch availability zones because that's your control plane nodes, and that does have that capability. Machine deployments do not, and there was actually talk about that in this week's yesterday in the cluster API meeting. It's not planned for the near future either.
Makes sense.
So tags would be the way to do it.
Would you view AZs as vSphere clusters within a vCenter? Open question to anyone. Is an AZ a vSphere cluster within a vCenter, or is it a higher level concept where individual vCenters, completely separate sites, utterly control plane disconnected from each other? Because I mean, the true definition, in my opinion, is that there should be no shared component, even vCenter, between AZs. But that does make scheduling challenging, because then how do you schedule K8s clusters onto those? You would have separate instances of CAPV or whatever it is that you're using to schedule them. But is vCenter that much of a, I suppose it is from like a storage perspective, because CNS exists within that. If you have a vCenter failure, you can't provision volumes, and that would affect all your AZs. I'm just curious what people's opinions on what an AZ is in vSphere land.
I think it's an interesting one. I think that's an interesting question, but in the end, I'm not sure that vCenter falls under that, because AWS's API is singular across every region and availability zone. And if the API were to go down, if the EBS API were to go down, then you don't get EBS provisioning of volumes as well. I think that the API level can be separate. It's the infra that needs to be separated in availability zones, right? And DRS and HA both work if vCenter is down. Or DRS doesn't, HA does though. HA will still work if the vCenter is down. So you still have, in terms of availability, I view availability as, is my application that's working right now going to continue to work? Meaning, can it be standalone and continue to run? And then there's higher levels of what you need in terms of functionality of, okay, can I provision new volumes? Can I provision new nodes? Can I do a scale out? Can I do all of that? That's already above the idea of an availability zone. That's a system-wide issue, at least from my perspective there. And I think availability zones, the way that CPI has viewed it in vSphere, is whatever you tag. So the three objects would be either a host group or a cluster or a data center. Cluster API limits that to cluster or host group though currently, because CPI does support multi vCenter. And then because you need, in the end, what we have to realize is public clouds, right? There's the availability zone in a region, and the two of them have to exist in order for it to work in Kubernetes. So the region is vCenter or a data center, and then accordingly, the level below that would be your availability zone.
I think it also kind of depends on what the risk profile is you're trying to mitigate against. I mean, this is true just for in a general sense. I mean, a lot of customers we're seeing coming from the infra side, right? So they may not even be familiar with AWS's concept of an availability zone, and that they view things very much from well, or at least what we're trying to protect against. It's either a single host failure or it's a data center failure. Very rarely do I see discussion of anything in between, right? There's not usually talk of a rack failure, right? Within a campus, you might have a data center failure. You still got somewhere else on the campus, but in the Netherlands, at least, you're usually talking about a different city. But when it comes to mapping these concepts, the constraint there immediately becomes vCenter. But you're right, Scott, because there is a difference between, is my app still running versus all these other ancillary functions that I would be used to from a vSphere environment. The funny thing is, most customers I've talked to, they don't consider that difference. They simply say, look, yeah, the application needs to keep running, but to be able to provide the service that we as infra are providing, I also need some of those ancillary functions to function. If they're not functioning, then my service is not functioning. And depending on the environment, I mean, some of that stuff can be very, very critical. It kind of depends. I mean, I can imagine plenty kinds of processes that require work, that rely on more than just the pod being up, but require some kind of storage provisioning to be available on demand, by minute to minute scale, and ditto the other stuff you would lose. It's kind of hard to map. What I've seen with TKGI, at least, is very often within one data center. The scale of customers in the Netherlands is not very big usually. So we're doing host groups within a single cluster, or it's separate clusters, but there's not many ESX hosts. And then I do wonder, like, what exactly are they then? What are they protecting against? Because there's the first three hosts, they're in the same rack as the second group of hosts. So why are they separate clusters? And I have a little bit too often seen them do this to fill in the requirement of Bosch AZs. So it's the reverse world, right? Where they think, oh, apparently this is needed, so we'll do that.
The way we used to construct vSphere clusters was either completely arbitrary, or whenever I worked at at an MSP, was based on the hardware that we were using. So cluster with R720s, cluster with R730s, cluster with R740s, and they were managed separately because we had different bun patching, baselines for them and firmware for them.
Levels, yeah.
Doesn't matter when you're talking about AZs. There's availability didn't come into it as a concept whenever you were constructing those things. Whereas now, if you were to construct vSphere clusters based on app availability from a top-down perspective, the way you would really do it is a separate rack or separate row or whatever. And if they're all in the same rack, they go all in the same pool, because the reality is, if you lose the rack, if the power goes out on one of the PDUs or both the PDUs, then you lose all of them. So they're not really AZs.
Yes. So it comes back to, what are you protecting against exactly? And this is where it becomes a conundrum, because one of the most attractive features that the vSphere ecosystem has when it comes to data center redundancy is vSAN stretched cluster.
Oh, yeah.
So naturally, people will ask this question: hey, can we install Kubernetes on any Kubernetes, right? On vSphere stretched cluster?
Yeah.
And of course, the answer is, well, I mean, technically it works, but it's not supported. And I had there's a wonderful little discussion in the vExpert Slack on this, where I basically tried to explain to a few people, say, look, this is a very logical question people are going to ask, especially coming from the infra side. It's a sexy feature. It's a great feature. It's one of the best availability features VMware probably has in a product. Of course, people are going to run Kubernetes on it.
It's the way we've always done things.
Exactly. So and then it's up to me to say, well, look, I mean, it'll kind of work. It'll work from an HA perspective, but it won't. It doesn't. You kind of ignore all of the availability stuff built into Kubernetes, because it's not. It's not. You need a three-way split or a two-way split. So at least a three-way split, and that's not available in that way.
Well, can I ask you? Even though I work for VMware, I'm ignorant on this, but why is it not supported? Does anybody here know?
Yeah, I mean, I've been neck deep in these conversations for a while now. Stretch cluster is our #1 requested feature for TKGM and TKGS. And I can understand why, because, we talk to the vSphere crowd, and that's the way they've always done things. K8s is just another workload. It should run on stretch cluster. And like Robert was saying, yeah, it'll run on stretch cluster. You can install it, but the operational complexity and the failure modes are so complicated and so contrived that you should never do that in production. Honestly, is my firm belief that if you're going to do AZs with K8s, you need 3 sites, and a 2-site stretch cluster you would perceive would give you more availability. The reality is K8s was never designed to run on something that if you lost all of it simultaneously, so let's say all your 3 control planes are on one site and you lose that like that instantaneously, okay? etcd goes into a state where it is not even read-only. It will not form a quorum if it comes up on the other side, because it says we all have the same failure timestamp, something went wrong. And it will just sit there until you manually intervene and choose which ones are the winner, risking split brains and all kinds of really nasty data corruption stuff. So like there are very good reasons why we don't support it, due to etcd bugs, kubeadm bugs, Cappy bugs, you know, the whole way through the chain, because simply K8s was never designed to be failed over like that. It is designed for applications that know, or rather more critically, don't know that they are part of, you know, different data centers or whatever. They should be completely decoupled. So there's lots of good reasons why we don't support it. It doesn't stop it being our #1 requested feature, because that's the way people have always done things.
Yeah.
Is that #1? Is it above? Is it above data store clusters for CSI?
Yeah, data store clusters. Technically, data
That's
store
not
clusters are
#1.
supported, but you need to pick the data store inside a data store cluster, so it kind of defeats
And
the
turn off
purpose.
storage DRS, so you don't get the benefit of the data store cluster.
Right,
Yeah.
exactly. But this is the thing, right? Is I find that whenever I challenge people as to, okay, why do you want to run it on a stretch cluster? What reason? What has the app team or the platform team told you that says that you need to have a stretch cluster in here? And there is no answer to that, because they haven't asked and they haven't been told. They do not know that this is a requirement, because it's not a requirement. So what they're trying to do is really engineer something that no matter what they do at the app layer, it will stay available, but it's just not how it works. You can't do it that way, at least today.
Yeah, and of course, people forget what stretch cluster was invented for, right? It's a storage play mostly. You know, it only becomes available as a concept if you have storage replication in some form. So, you know, stretch cluster was a thing before vSAN was a thing, right? I did stretch cluster on EMC vPlex, and that worked fantastic. And you could run Kubernetes on that as well. You still have the same problems, but of course, the irony of that is that Kubernetes, you know, doesn't care about storage in that way. You know, the relationship it has with storage is very different. So of course, now this is where my Kubernetes knowledge starts to break down a little bit. It's simply because I haven't done enough with it in practice. So so when we're talking about persistent volumes, right? How does this map onto this three-way AZ concept? Because again, like what I'm used to, what I've seen is with the storage is always shared, because I'm always doing it within one data center. But if you were to actually go with the Amazon model, how does that work then with persistent volumes? If also the storage is 3 separate layers, or is that currently a no-go?
No,
the storage isn't replicated.
The storage is not replicated. The storage is local only.
Yeah. So
that means
all of
you
your
use
pods, you set which availability zone they're going to run in, and wherever the persistent volume is, that's where the pod's going to run. So if you have 9 worker nodes, and there's 3 in each availability zone, if you bring up now a pod that needs a persistent volume and that gets scheduled in availability zone 1, that pod from then on, or any pod that is going to use that persistent volume, will be in availability zone 1. What you can do in like a stateful set though, Robert, is you can set a distribution of the stateful set so that you get like 3 replicas of, let's say, a RabbitMQ cluster. You could have 1 in each availability zone. So you would have 1 persistent volume in each availability zone and 1 pod always running in each availability zone. That all exists and has been, it does make, I will tell you, availability zones in Kubernetes make the life of a developer terrible, because they need to write the YAMLs that deal with availability zones, and Kubernetes is a pile of YAML and add 15 piles of YAML on top of that in order to deal with availability zones correctly. But they have that capability then.
Yeah,
I think it depends. Sorry, go ahead, Robert.
No, go ahead, Miles.
I think it depends on the app, right? And anytime I've been asked, can we replicate the storage and have the pod and its storage fail over across AZs, the reason they're asking that is the app was not designed in a cloud native fashion. If you are using a storage system that is a cloud native storage system, say Cassandra, Redis, Mongo, MinIO, whatever, self-replicating, understands AZs itself, can do its own replication, can, you know, synchronously or asynchronously copy data, you do not need that, because then you just use the local disk that's on that site.
you do not fail over across AZs, you fail over within an AZ, right? The persistent volume and the pod concept is designed to protect against a host failure within an AZ, but you don't ever fail over across AZs. There's no reason to do that. They're supposed to be completely separated in all ways. And if you start binding storage replication at the infra layer, that AZ is now not an AZ. It's now, those two AZs become one AZ because you have a shared failure mode, you know?
So what is the suggested solution for somebody who's got the legacy app that can't handle the replication up at the app level? Is it perhaps to not even host it on Kubernetes and just
leave it in VMs,
put it in,
100%.
put it as a VM, and
Yep.
then
So
it
this
should
is
work,
exactly,
right?
yeah. So you preempted my next question. That's exactly, because what we're seeing again with our customers, so just see through our lens, is a lot of people are just starting to play with Kubernetes now. So a lot of what they're playing with is non-cloud native application stacks. They're monoliths being put in Docker, basically. That's what they're starting with. And one of the things I have to explain to people is to say, look, all of your assumptions about storage are out the window. All your assumptions about backup and restore are out the window. It's all different. And what's particularly hard, and this is where things get really complicated. I'm dealing with customers who are struggling, and I think everyone's probably struggling with this. Who does what? Who has which responsibility when it comes to exactly this layer of platform management? Because if some of these developers are just getting started with Kubernetes now, then to unload all of these extra requirements on them, which translates to like 15 extra YAML, is a huge burden. One of the things I'm looking with is like, where do you split the difference between a platform team and a developer team? How much of this can we unburden the developers by implementing this in policy in some way? Taking care of some of that abstraction layer, basically acting like you're an Amazon, right? Because because this is exactly the kind of stuff the developers did not want to deal with and did not want to have to deal with. Thinking about storage topology, thinking about AZ topology, they just want to deploy their thing. Now, of course, we can force them in certain directions with policy and just making agreements with them, right? And just making a rule book and say, this is how you deploy an app in production. Thou shalt not do it in a different way. But that's really tough because the amount of experience out there to do this properly is still so limited. Something I'm really, really struggling with.
Sounds like you need a platform. Honestly, like this is why you build a PaaS, or this is why you buy a PaaS, is to you've got these concepts, these availability concepts, these distribution concepts, whatever it is that you want to be a part of all of your apps, and it's boilerplate. Frankly, it should just happen. So you build or buy a PaaS that takes the container and wraps the YAML around it and deploys it for you. I don't think the developer themselves or the person that's interacting with the building the container is the person that needs to be responsible for building the K8s manifest and deploying it as well. Because like you say, if you're telling them here's all these requirements, you're relying on them to follow the guidelines and all that kind of thing. So how do you ensure that that's really the pattern that they follow? And I think the reality is that you need a pipeline that does that for you. I don't think you can just shove that towards the developer and say, here's a boilerplate.
Yeah,
I agree completely.
And then if you think about the storage, so what are the storage layers that do this properly, that are AZ aware, that do the storage replication for that create an intermediate storage abstraction layer? Well, it's things like Rook and Ceph, tool sets like that, Minio. Who's going to manage them, right? So do I place the burden of suddenly learning all those extra infrastructure-ish tooling layers? Do I place that burden exactly again with the developers or with the platform team? So, and again, no one knows where that responsibility should be. I mean, we saw the same thing in Cloud Foundry, where it's like, well, these additional services you need around Cloud Foundry. Oh, I want MySQL brokerage, hosting MySQL as well. Suddenly you have to be a MySQL database admin. Oh, and a Redis admin, and a RabbitMQ admin, by the way. And all this other stuff. And the same is going to happen now with platform teams that are rolling out Kubernetes for their developers. Same questions are being asked. And so it's either, so you end up with just the plain YAML. You also end up understanding these kind of services layers. It really makes the barrier to entry so much higher because it really only makes it possible to adopt Kubernetes at a certain scale, when you have the people and the expertise to actually be able to do a proper platform deployment. And like, yeah, I mean, it would be great to have a PaaS today that did all that for me. We're not quite there yet. And I mean, CF, you know, PCF especially was great in that way, but you know, that's kind of going away at the moment. So you know,
look at cartographer.
No, I know, I
Look at
understand.
cartographer. It's getting there.
I understand the intention there, but we're not there yet. And
No.
So it's, but even if we were still, right, because even if you bake a lot of those layers and into a PaaS, you boilerplate it, you build up all these extra features inside of, you know, what we might be end up calling, you know, the new version of what is now, say, TAS. Even then, you know, you still need the expertise somewhere. You still need to be able to troubleshoot. You still need to be able to manage all those layers. And the burden that places on infrastructure teams, well, on platform teams, if they're coming from infrastructure, they understand the bottom half of the stack, but they are clueless about the top half. If they come from the developer side, they understand the top half of the stack, but they're clueless about the bottom half. And
Yeah, I
you've
think
got
you've made
S3 in the middle where people just fight over, no, it's the developers thing because it's S3 and it has the word API in it. No, it's the infra team because it's storage.
Yeah, but I won't go back onto my oh no, we don't have enough skilled people hobby horse. I'll leave it there for now.
Yeah, I think you made the point before in user group meetings.
Yeah, I
I
keep
fully
making the
agree
same
with
point.
that. You know, these are likely different people, so that if something isn't working right, you're going to have to bring in a team and go through the meeting cycle of figuring out where the problem is, maybe with observability challenges, so that you've talked about the difficulty of 15 different YAML files, but that's just even the act of bringing home the puppy, not maintaining it. And, you know, that gets it running in the steady state, everything's working condition. But really the harder problem is probably the troubleshooting when inevitably something goes wrong. And are there any big picture observability solutions that kind of, you know, there are a lot of products that contend you steer all the logs here and some kind of AI machine learning is going to help you out to diagnose issues. And sometimes they save you, sometimes they don't. But I don't really know if there's a solution that even if you grew this stacked up infrastructure going to Kubernetes, going to apps, that would help you out a whole lot, so that you wouldn't need a big team of experts on each individual layer and could still solve problems.
I think that, yeah, part of the challenge is that a lot of this is custom because a lot of it is app centric. So it inevitably ends up that you need to have custom monitoring and custom logging added in. You need to build custom dashboards. And realistically, you know, Kate's is more of something, if you're building a SaaS app that you're going to resell, then you're building an internal website for, you know, a database front end or warehouse management or something like that. It's some of those things, yes, monoliths are bad, but we have, you know, answers for failover and HA for monoliths that don't require a massive team of people to look after. And I think realistically, like if you're going to use Kubernetes, that you're probably more looking in the area of, we are going to sell software, not really, you know, issue it internally to internal customers. So, I mean, I could be completely off the ball there.
I think in terms of who Kubernetes was aimed at, you're completely right, or who it's right for. I think that unfortunately in today's world in high tech, everything is buzzwords. So we're going to the cloud. Why? Because we need to be in the cloud. Why? Because the CTO said we should be in the cloud. Why did he say that? Because it's a buzzword. Same thing with Kubernetes. We have people that are moving applications that are monolithic into a container as an entire monolithic into one single app, not following any of the 12-factor app, whatever, just to say we are containerized, we are cloud native. No, I'm sorry, you aren't. You're in a container running a monolithic application. Unfortunately, though, that is the case that we're in the world. And that's where a lot of these issues come, because availability zones are easy when you're dealing with 12-factor applications, because 11 of the 12 don't need any persistence and you're all good. The issue is when you're running applications that are not built for this in Kubernetes. And then, that's where I think things like Kyverno, or thank God, finally, Gatekeeper just added mutation policies. There are ways, even without a full-blown pass, that you can bake in some of these things by mutating any deployment that comes in and adding a pod distribution budget, adding in automatically to a stateful set the separation amongst availability zones, and setting up anti-affinity rules, right? There are ways to do this, but they're going to be specific to the customer's environment or the environment you're deploying into, because they may have 3 availability zones, they may only have 1. So the changes that you have to make are different, but there usually is a relative standard in an environment of what that best practice should be. The issue is getting that documented, because I think the knowledge exists out there. It's just no one has actually sat down and said, okay, these are the 10 general topologies of vSphere environments we see. What are the best practices? Doesn't really exist in this world of policies, at least. But I think mutation is definitely a way of getting around this, because you don't put the burden on the developer.
Exactly. So that's the first thing I was thinking of, and it's something I'm probably going to do particularly with one customer I'm working with now. We're probably going to set up some of these kinds of policies around availability, around these kinds of rules, so to get them started in the right way, and also to get the platform team comfortable with using, in this case, Kyverno. So I'll have the first, and it's a pretty standard topology, but maybe it's up to the groups like us to start writing some of this stuff down.
Well, I was actually just thinking that maybe, when it comes to Kubernetes and operationalizing it and coming up with like a set of guidelines, it's like developing software itself. We got to have an MVP. We got to start somewhere, because it's very easy to rabbit hole Kubernetes and go, okay, the ultimate design is completely separated, multi-AZ, it's got OPA and Gatekeeper, and you're using, services toolkit or whatever to have separate clusters for different services and all these kinds of things. And you can think about it for literally years and not actually do anything. But I think like having a starting point, which is, right, we got a single cluster. What do we do within a single cluster to provide availability? PDBs, anti-affinity, stateful set affinities, all that kind of stuff, right? And we go from there and we say, okay, that was one cluster. How do we solve that for 3 clusters or whatever, the same apps across 3 clusters, and just build it up bit by bit. And then we can look at more perfect scenarios, like, okay, instead of deploying stuff all into these, single clusters, how about we have services clusters, and we have abstraction clusters that provide an API that you request a service back from, and you get like a CF style binding, right? I want MySQL database, or it's a bad example. I want a Cassandra database, for example, and it gives me a Cassandra database that provisions somewhere else on a different cluster, but what I get back is a URL. So I think it's one of these things that we can build up over time. If you try and do it all in one shot, you'll just get overwhelmed by the stuff that's out there.
Well, let me ask you, what would be a good form for this? Somebody threw out the idea that there's maybe 10 different permutations. Is that within a reasonable ballpark? And would you start it by just sort of classifying apps, or get very specific, like here's a best practices white paper for Cassandra on vSphere for high availability, and focus it at the app level rather than kind of generic characteristics of an app that would potentially apply against a bunch of them? And also, what would the sell by date be on these if we compose these white papers or whatever they are? Is it like bringing home the puppy where they go stale in a year? And then, bad information is sometimes worse than no information if things keep moving enough that they go bad, and we'd really be signing up for maintaining them in addition to doing the first edition.
I think that
Sorry, Scott.
The availability zone code in Kubernetes is relatively static and isn't changing much. There isn't much change happening around that because all the knobs exist. And Kubernetes is not around building higher level things above those knobs. It's about expose every single knob and you figure out or bring a platform that, you know, best suits those knobs. I don't think that a white paper like this should be something about, you know, Cassandra or Mongo or Rook or anything like that. I think apps generally split into 3 types of apps. There's non-persistent applications. There's persistent applications that need a underlying something to do the replication. And then there's persistent ones that deal with the replication themselves. And to split apps into those 3 and give lists of these are example applications that fall into these things and what are the characteristics of those, and then accordingly best practices for the 1, 2, 5, 10 different vSphere topologies that, you know, there's enough data out there to figure out what those topologies that exist by customers are of, you know, multi-rack, single rack, multi-cluster, multi-vCenter, multi-data center type topologies, and then accordingly set with those 3 application profiles what the best practices would be. And the benefit of doing something like that also is I think that a lot of this knowledge would be helpful for AWS and Google. And it's not just a vSphere specific thing. When you start talking, okay, what are the best practices of pod distribution budgets and anti-affinity rules when running a persistent application that doesn't deal with replication itself when running on Kubernetes in a multi-AZ environment? That's just a question that there isn't the answer to in a clear, concise way on the internet.
Yeah, I think there could actually, it could be even more generic than that, Scott, as well. And like you say, a lot of the K8s APIs are V1 or are stable at this point and are not going to evolve in any real significant way. So like PDBs and anti-affinity for pods and all of those kinds of things like the region zones APIs, those are all fairly static. And I think we can be generic about it and say, what is the best way to distribute an app and use PDB and use anti-affinity to ensure for like those stateful workload types that Scott mentioned, non-replicating and self-replicating, what is the best way to run those? Because that, again, like Scott said, is generic to all clouds. Doesn't matter if it's on vSphere. If there is a right way to run a non-replicating stateful app inside a cluster using PDB, anti-affinity, stateful sets, that is generic across all K8s on cloud or on-prem or whatever. So if you take it, you know, you eat an elephant a bite at a time, little bits and pieces like that, and then you can say, right, what is the best way to bring that all together? Well, here's our best practices on PDBs. Here's our best practices on zones. And these are the kinds of applications that fit these types of deployment models. I think it would have a longer shelf life than most normal things in the cloud native space, let's say.
Yeah, I just, I mean, my first thought is, well, surely others in the Kubernetes community have been thinking about this, and there must be something out there that's already like this. What I do know for a fact is that, to bring it back to the VMware world, what I do know for a fact, there's nothing out there today that maps that onto the VMware solution stack.
Right.
And, you know, and that's kind of where my first thought goes, because I'm thinking of all the infra teams that are currently having to go down the, you know, being asked to go down this Kubernetes path. They're the ones looking for that. So, you know, it's obviously more vendor centric, but it's kind of the world we're more in. You know, one of the things I'm trying to achieve with the customers I'm working with now is to create something like this, but for the so it's a very constrained scope, right? It is a best practices set for TKGI and TKGS and TKGM for the kinds of customers that we deal with, which are pretty small scale stuff, because I need to be able to explain it to infra teams, the customers, and I need to explain it to infra consultants on our side. So it has to be, so I'm kind of already doing this, but it is a very constrained scope and it's very VMware oriented, obviously. And when broader than that, I totally agree, by the way. I mean, if there's one thing I have noticed just broadly in the Kubernetes community, what I've seen of it is that not enough thought is being put into exactly this kind of stuff. And if the thought is going into it, it is coming top down, right? It's very much from an application architecture point of view without taking, people tend not to want to worry too much about the infrastructure because many of these people are used to doing it on public cloud, where it's abstracted away and invisible to them.
Mm-hmm.
The funny thing is, even there, I see people making assumptions that they shouldn't be making. I'm not hugely familiar with any of the big public clouds, but I do know that things are sometimes not always what they seem when it comes to things like storage replication. I'm thinking of Azure storage accounts in particular, and what they do and do not do for you, and what some customers think they're doing for them.
I think, what is it? They say the two hardest things for an open source project is finding a name and writing documentation. In the end, there's a reason that SIG docs in Kubernetes is the SIG that has been requesting for more people to join for the longest time. And I don't think have any new people in the last probably decade. No, all the new SIG docs people, it's awesome. Just a few people just joined now, but SIG docs and anything that has to do with documentation is always the hardest part in any tooling system, especially something as wide and open as Kubernetes is, because it really is the platform of platforms, as Joe Beta likes to call it, right? It isn't a platform for applications. It is a platform for platforms to run applications like Knative, like OpenFast, like dozens of other systems out there that are built to make it easier, because Kubernetes is the hardest system I've ever dealt with in my life because it has a million knobs. On the other hand, the reason that we are moving in this direction is because all the old time passes that exist out there, the CFs, the S2I, all the things that exist from different vendors and different things were way too limiting and only sufficed for a subset of the types of applications. Kubernetes can work for any type of application because you have all the knobs. Now, we took it a bit too far, and now how do we bring it back in a bit, but still allow that flexibility underneath? And that's the real complexity here. I think it's an unsolved issue because no one has been able to tackle the documentation, because usually the people with the knowledge with the deep enough knowledge to actually say what the best practices are the people that are probably the worst at writing documentation, AKA engineers. Engineers are great at writing code and terrible at documenting as a general, I think. It's just a hard thing, especially in such an evolving world like Kubernetes, where every few months we have a new release with, I think 52 new features that came in 123, which is going to be released next week. It's just insane the amount of new capabilities we're getting.
And you might at first glance think the documentation is cheap in terms of human resource, but it never is. And it's like coding, where you can't just code it and assume it's good. You really have to test that documentation or have written it while you're cutting, pasting from an actual working example, because there's nothing worse than bad documentation that leads you down a path that just flat out doesn't work.
Exactly. And there's no shortage of bad documentation out there. That's for sure.
Yeah, that seems really interesting as a concept. I would love to contribute to something like, best practices for, single K8s cluster, my first K8s cluster or whatever you want to call it. And you have your stateful app that doesn't do replication. Okay, right. We'll cover that. And we'll say, right, this is because that's where most of the VMware customer base is going to be. This is probably the best that you can get, but there's a lot of drawbacks. And then we can illustrate other examples like, okay, this is if you take that a step further and you make your persistence layer now self-replicating, what's the best way to do that? And what advantages do you get of that over the previous model? It's not a trivial change, but if you do make the change, here are the benefits, that kind of thing. It's just a colossal amount of work.
Yeah, the other thing is, I think the pool of potential people to do this documentation becomes smaller as you become more specialized and require more things. There is readily discoverable things for running Kubernetes for kind of home lab scale, because there are tens of thousands of people who are trying to learn it in a home lab. and figure they might as well write things down as they do it. So that kind of stuff is very well covered, but not too many home labs are going to have 3 availability zones. And it means that you're going to have to get the people who write this are going to have to be with vendors or very big organizations done by people who have regular day jobs that aren't writing documentation. And so, I'd love to see it, but anybody got ideas for how we'd cause it to come about? I mean, it's fairly trivial, I think, under the auspices of this user group or Kubernetes in general. We could publish the things once they're written and get them exposure, maybe get blogs, presentations at conferences, but the hard part is getting the actual documentation written, testing it, and finding people who are authoritative to do this documentation in the first place.
Yeah, but I mean, it can start with just some guidance, right?
Mhm.
And that's what I'm going to start with within my company, is just create a standard set of guidance across these topics, saying, okay, these are the layers involved. This is how we'll this is like the minimum set of policies you can introduce for any Kubernetes POC you do that will enable these and these and these gates and it maps onto these and these and these vSphere availability concepts. That's already so much better than any guidance that's currently out there today, and that's relatively easy to achieve. I'm kind of hoping to have something like that internally within the next few months, just within my company. At some point, if I have the energy for it, I'm going to stick it on GitHub, and then it'll be there, and I'll probably do a post about it, and it'll probably make a brilliant VMUG session.
Well, I'll tell you what, if you want to amplify it further and get an audience,
no, I'll
this
let
user
you know,
group can maybe do it, because so far Miles and I, under the auspices of this user group, have been getting a maintainer track session at the KubeCon events. But there's nothing wrong with members taking over that role or doing joint presentations, and I'd be happy to put that on a future KubeCon as the submission for this user group's presentation at KubeCon, if you wanted to get a forum to get a big reach. The nice thing about those is I think that the CNCF itself actually ends up publishing the deck and the video, and it gets really good search engine placement by virtue of being underneath the CNCF rather than just some random blogger out there, so that you'd reach a lot more eyeballs.
Yeah, I'll keep that in mind, but no promises. I know myself. I have way more ambition than I have energy. So
yeah,
let's see what happens.
The deadline for KubeCon Europe is, I think, December 17th for a regular CFP, and then maintainer tracks, I'm guessing. They haven't actually even put out the invite for those, but if history is a guide, that's going to be January-ish in terms of when the deadline is. So you can't go there last minute and land one of those KubeCon sessions. It's pretty much a 6-month in advance kind of thing. But
yeah, well, we'll see. I'll be really happy if I can just finish some internal guidance and help this one particular customer out with using them as the use case for it. I'll be really satisfied if I just get that done.
Yeah. So let me know if you do want to go in that direction, or anybody else on this call, or anybody watching the video of this meeting afterward. Reach out to me, because even if you write something up internally, I'd be happy to sign up and do some work to kind of genericize it, proofread it, and maybe turn a written document into a PowerPoint deck for presentation. Maybe if there's multiple people doing that, we could do this as a panel at a future KubeCon, or any of the other tech conferences for that matter.
Yeah. I think
I won't volunteer Miles for that, but he might be interested in it too, maybe.
Oh, for sure. But I think, like Robert, what you were saying is, if we have some stuff like this, where maybe what it takes is that we have an example app, right? Spring Pet Clinic, or some such thing that we say, right, we are going to make this available on case, and this is how we make it. And we have a Git repository that shows the different iterations of just deploy it as a pod, put it into a deployment, replica set, stateful set, pod disruption budget, and just piece by piece build it up, layer by layer, add more and more complexity so people can see the different iterations and what pros and cons each layer has. Maybe that's the approach, because that's nice and iterative. It's small bites that we could take.
Yeah, I agree. I think that would be a great approach. Yeah.
I agree completely. And I think that if we do want to go down that white paper type, best practices docs and whatever, I would be more than happy to join any like working group or of whatever and try and help out there and all of that. Maybe we can set up a kind of working group on a doc like that if there's enough people that are interested to, you get someone who's an expert in vSphere, someone who's an expert in Kubernetes, someone who's, whatever, in the availability world of Kubernetes, even if it's not in vSphere, but someone who really understands vSphere, so I can get people just to sit together in a room or a virtual room on Zoom, and to kind of brainstorm all these things and talk about, like what you were mentioning, Miles. I'd never even thought about that, of the issue with the stretch cluster on vSAN, right? But once something like that comes up, or what the issues are with storage DRS clusters, which I know the CSI team are working on that, but like all of like these different things that you bring them up that have to do with availability and whatever, all those things you bring them up. And then, we can come up with what the best practices are and then start to document. But I think it's really just a bunch of brainstorming sessions that have to go on and really talking about the edge use cases that, and this happens here, and what do you do in this case? Or what are the failure modes of host groups, and what are the benefits or negatives of that? Or what is the best? I've seen two different topologies with clusters, either people that do a cluster where every host is in a different rack. I've seen clusters where every host in the cluster is in a different rack, usually in very large environments. But that way, a cluster doesn't have a single point of failure. And then a VM, a monolith that's running in there, can always fail over to a different host. Or do you design your application to be spread across multiple vSphere clusters, and each cluster is actually like a traditional availability zone where it's a single rack, right? And you have these different topologies. Each one has a plus and minus. What works better for Kubernetes? It's an interesting question, and I don't know. It would be an interesting conversation to have there as well, right? What is that best practice?
Yeah.
We could bring it up in the Modern Apps vExpert group as well, because there would be people that are keen to contribute in there too, I'm sure.
Definitely. And feel free to then send that to me, because I'm not a vExpert.
Okay, I think we're reaching the time limit here, but it's been a great conversation. I think summary is that we've got a plan to make a plan to do something about this, but the plan's not there yet.
Very government.
To follow up on this, one thing I want to bring up before we close is the scheduled next meeting in January is the week of January the 1st. I'm not sure how many people are even likely to be working that week. Whether we should consider just canceling it and having the next meeting in February instead. I probably should put a poll on Slack instead, but just curious as to what the thoughts are in this group.
I'm not going to be around, but we could move it, maybe a week out of cadence from January if we didn't want to wait till February, something like that. So maybe that's an option, skip or move cadence or something.
Okay.
Yeah, maybe do second week of January.
Yeah, I'm willing to try it, although in other working groups, anytime I move it, what I find is half the people show up at the original one without having noticed the move. And then hardly anybody shows up at the move date, but no harm in doing it. I'm willing to. Okay, even that, I'm not sure, is it unanimous you want to just move it, or should I put a poll out and maybe a broader group would respond to it?
I'll be in the office, that's for sure. So I'll be there if it is whichever week.
And the question is, I'll probably work. And the question is, will I be sober? You should do a poll. I think it's more fair.
Okay, I'll do a poll,
exactly.
and the choices will be, I guess, hold it normally, cancel it altogether until February or move it. And I'll put it out on the Slack channel. Okay, with that said, I'm going to call this to a close. I'll upload the recording sometime. And thanks for coming. You've been great, some great conversations and great ideas contributed. Bye.
Later, folks.
Excellent. Thanks, everyone.
Bye.
Yeah.